The next example here is a think, pair, share. So this is a word problem that you should attempt on your own. This one is looking at the speed of an express versus a local train. I've given you here in red the answer to this one. So at this point, pause the video and try this on your own. See if you get those correct answers. If you would like to see how I solve this problem, then come back. Or if you had trouble solving it and you want to see how I did it, come back and watch the rest of the video. So go ahead and pause. All right, so we're back. So we're looking at the speed of two trains, an express train and a local train from Pittsburgh to Washington, D.C. So we've got Pittsburgh to Washington, D.C. And so I made a little picture, a little schematic showing the starting point for both trains and the ending point for both trains. And so here is, the express train at its starting point, and here's the local train at its starting point. And they're both starting at Pittsburgh and ending in Washington, D.C. So that's what these arrows are meant to represent. And from the word problem, the time that it takes for the express train to make that trip is 4 hours. And the time it takes for the local train to make that trip is 5 hours. The speed or the rate of the express train, we're told, is the rate of the local train plus 12. And we're not given any information as far as the rate of the local train. So we just have to use a variable r sub l to represent the rate of the local train. Now, since we've drawn this picture, again, I can't stress enough how important it is to draw pictures, because from these pictures, you can see relationships. And the relationship that's really important to see drawing this really simple schematic is just to notice that the distance traveled between both trains is the same. Okay, yeah, you might be able to intuit that in your brain after a while, but it really helps to see it on the page. And you can see that the distance covered between the express train and the local train is equal. So you can actually see this with your eyes, okay? So when you make these illustrations, look for clues in the illustrations that you're making. And of course, this observation is key to solving this word problem. You need to have this observation in order to do it. Okay, so here I've created this table with express and local rows and these columns of rate, time, and distance. And that's because rate times time equals distance. And so, the rate of the express train I put here, the rate of the local train is there, the time it took for the express train to make the trip, the time that it took for the local train to make the trip, and then these two multiplied together is the distance for the express train. So distance for the express train is equal to this expression. And over here, the distance for the local train is equal to the rate and time for the local train, and that was 5r sub l. So now that we've got these distances figured out, from what we figured out earlier, these distances have to be the same. So the distance for the express train, which is this expression I wrote here on the left, and the distance for the local train is this one here. And so I wrote that down underneath it on the right-hand side of this equation. Now just went through some algebraic steps to get the rate of the local train, which is 48. And now that we know the rate of the local train, we can use that to find the rate of the express train. And so we know that the rate of the express train is equal to the rate of the local train plus 12. That was figured out earlier in the given. So we can substitute 48 in for the rate of the local train and add 12, and we get the rate of the express train was 60. So the speed of the express train is 60 miles per hour, and the speed of the local train is 48 miles an hour. Let me know if you have any questions.